Hello everybody, I'm going to have a little short video today. I'm making nitric acid by reacting sodium nitrate with sulfuric acid, which is what's currently in here. And the ratios are 101 grams of sodium nitrate and 58 milliliters of sulfuric acid, and there's 50 milliliters of distilled water in there as well. So we're just doing a simple distillation to get our impure product, and then we will be doing another distillation to purify the product we get from this distillation. So I'll show you some of the steps through which the distillation occurs, because there's some nitrogen dioxide gas which is produced, which looks pretty cool. It's a very deep red, orangey color, and yeah. So I'll be back when that happens. I don't know if you guys can see in there, but the solution, which was originally just clear, is taking on like a yellowish hue. That's all inside. But it's taking on a yellowish hue, which means there's probably some nitrogen dioxide starting to accumulate in the flask. Soon it'll be all through the distillation and it'll be coming out, if I can touch it, this end right here. Hopefully it'll limit the amount that is expelled at once. Okay, cool. And I also have a fan here, just in case, so it blows that way. So I don't want it, blowing at me. That's not good. So yeah. I don't know if you can see that, but you see that there's like a orangish tinge in the neck up here. That is due to nitrogen dioxide gas formation, although I thought there would be much more produced. So I don't know if there's something up with my reagents, or if it's just too early. But we'll see. Because it wasn't over there before, so it looks like it is spreading. And the nitrogen dioxide should precede any distillation that occurs, so we'll figure it out, we'll find out. Alright, I'll see if it gets any darker. There's our first bit of distillate. As you can see, it's pretty yellow in color, and there is like there's a yellow tinge in the flask, indicating that there is gas production. As you can see, this is in the reaction vessel. There is some sodium bisulfate that is crystallizing out, since the solution is reaching its limit. Is almost everything is now in the collection flask. It's been about an hour. So yeah, I'm gonna let this go for maybe 20 more minutes, and then once there's basically no liquid left, I will call it there, and then I'm gonna redistill. Okay, everybody, so we're back on another day, and now we're taking the nitric acid and fractionally distilling it to purify it and get it to the azeotropic concentration of nitric acid, which is 68%, something like that. And yeah, that's what's happening. So you can see the nitric acid down there with it's got some nitrogen dioxide impurity. That's why it's still yellow. And it's gonna come up here, and water will come out first because it boils at a lower temperature than azeotropic nitric acid. And then we'll collect the water at 100 degrees, and then until it gets to about 120 degrees, so about right there, and then we'll collect the nitric acid. So I'll keep you updated. So here we have our final yield of about 75 milliliters of 68% nitric acid. Nothing else really interesting happened with the fractional distillation, so I didn't feel the need to record it. The only thing that I feel might be worth mentioning is that I had to put some tin foil or aluminum foil around the fraction column to help get the nitric acid over, so that's a helpful little tip. So other than that, this is it, a quick little video. Thought that would be interesting to show you guys. So yeah, have a good one.